I'm so late, and I'm not even changed, and I need my morning coffee. What do I do? Well, I know this can make 14.5 ounces in 6 minutes, but I don't even have 6 minutes. What's a girl to do? Well, I guess I could figure out, based on the rate I know it drips, how much coffee to make in 3 minutes or so. That's what I'm going to have to do. With the help of my handy-dandy whiteboard and my college dorm mate, Carly Danoski, who took AP Calculus with me in high school, I think we can map out a solution. Alright, so first we want to approximate C prime at time 3.5. Now in order to do this, we want to use AROC, or the average rate of change, of the values that were given in the table of 3 and 4, since 3.5 is right in between 3 and 4. So what Carly's going to do is she's going to take C of 4 minus C of 3 over 4 minus 3 in order to approximate the derivative of C at time 3.5. So here she's just plugging in the values in the table. Perfect, and this represents the approximate ounces per minute.
So for this problem, it's asking us to find if C prime of t equals 2 at any point between the interval of 2 and 4. So first, in order for the mean value theorem to be applicable, C has to be differentiable and continuous, which is true for this problem. So all we have to do is use the table again. So we're going to do C of 4 minus C of 2 all over 4 minus 2. And again, using the table, we're going to plug in the numbers. So 12.8 minus 8.8, all divided by 2. And that equals 2. So we know that this problem does work. And there's at least one time between 2 and 4 which C prime of t equals 2.
Next, we are going to find the average amount of coffee in the cup from time 0 to time 6 using the interval given in the problem. Now, in order to do this, we are going to use a midpoint sum with 3 subintervals of equal length, like the problem tells us in the table. So, we're going to take the first subinterval between 0 and 2, and then we take the next subinterval between 2 and 4, and the next subinterval between 4 and 6. So using the Riemann midpoint sums, we're going to look in the table for the values of C of 1, and C of 3, and C of 5, so Carly can plug them into this equation. Alright, so she's just going to math that out. Perfect. Now this represents, like we said earlier, the average amount of coffee in the cup in ounces over the time intervals of 0 to 6 minutes. And remember the Riemann sum, that number out in front, that's just the difference between like the top intervals.
Okay, for this next part of the problem, we were given this equation that models the amount of coffee in the cup in ounces. So, it asks us the rate at which the amount of coffee in the cup is changing when t equals 5. So to do this, all we have to do is take the derivative of the original equation, which Allie is going to so skillfully do. So this, on the right side, is the derivative of the equation that it gave us. And then to find the rate at which the amount of coffee in the cup is changing when t equals 5, we just plug in 5 to the derivative.
At this rate, looks like I'm better off going to Dunkin'.
At this rate, I'm about to get the car, I'm about to take it up to Boston and get some Dunkin' and Quincy. Come on.